So in this demo, we are going to look at 1 terabytes of data copy over 8 nodes. Okay, so now let us copy the data from mapper FS into NFS. If you look at the screen here, so we are having 8 node cluster is running here. MCS mapper cluster we were using, and if we look at the nodes, all the node details are available here. 8 nodes we are using, and this is Grafana. Grafana is running in this cluster. Just want to watch the throughput and IOPS. And before we start the demo, just want to look at that Hadoop parameters which we set for this particular testing. So we are using 160 GB RAM and virtual core is 160, but actually this server has 32 physical CPU. So like this, all the servers has only 32 physical CPU. So just want to see that. You want to see that now all the servers. Just so if you look at that, all 8 servers have only 32 CPUs, all the 8 servers, and but we are just using multi-thread, so that's why we are having 160 just to match the memory of the server. And let us get into the demo now. Let us look at the data copy. So let us get into server. Before we do that, let's clear the space, clear the cache, and swap all those things in swap memory, clearing the drop cache, and clearing the memory swap off and on here. So we are running ESLH. It will run parallel in all the servers. It's completed. So now log in as a mapper user. Yes, I'm clearing the screen. Okay, so now I'm going to run. Let us see that what is this mapper FS file system space. Just Control C, I did that. Hadoop FS ls space. Okay, look at that. Folder TG and disk space TG minus H. It will tell you how much space each folder, close to 1 terabyte, and the number of files in this H1 is 7.3 GB, 128 GB, 128 number of files. Start from 0. Okay, so now let us check the destination also. Let's clear the space from the destination. I'm just going to clear the destination, remove all the destination directory. So here we are running DG NFS1, and I also have one more folder, 2 terabytes one. I deleted both of them. So if we look at that, if we look at this, where it is mounted here, this one is mounted in all 8 servers. So if we look at that, all 8 servers, it's showing that mounted in all servers. So here it's mounted in a different IP for the same flex group volume on a same mount point in all the servers. That's very important to access NFS data from MapReduce function. Specifically for Hadoop DCP, we need to have same mount point across all the servers. So this is the new feature introduced in Hadoop, I think 3.x onwards. I also hear that is 2.7 onwards it's available, I think so. Next one is, it is very useful for the Spark workload. That is what the entire industry is going towards. Now let us run the workload, clear the screen. So now if I look at here, number of nodes, I have 8 nodes here. The font is a little small, but I just want to show the in a single line, so I am having like this. And here I want to show the applications. So running applications is nothing is running now. So here also Grafana, nothing data, not much traffic. Let's run the statistics so periodic in storage. Now let us run the Hadoop DCP command, and we are using the 5 cores per container, copying from MapRFS to NFS. Just enter. Let me look at that, how the servers are used here. Just refreshing the screen here. Say number 1, okay, application server first started now. Now number of servers usage is going on, gradually increasing. Let's keep on increasing now. Let me go to the number of running servers. So which one application is running? Go to the application master, and if I look at that, almost 128 process running. It's going on here, and it's going on 128 GB. So 128 files we have. That's why 128 process running in the background in the running process. And if you look at the screen in this side, that storage throughput is going on here, and then you can see the traffic 8 to 9 GB is going on, and the disk read, disk write, sorry, this is DCP copy operation. So disk write also you can look at here, and the Grafana is slowly coming up. It's picking up now. So far close to 4 gigabytes per second, that is 4000 MB. IOPS perspective close to 20,000. So here also close to 17, 18, 27, 25,000. IOPS is gradually increasing. Okay, so now let us look at the CPU utilization on the server RHEL1. So we are using net data. So here close to 47% of 45% of CPU on that particular server is used. It's gradually increasing, and this number of servers we monitor here. You can also look into that jobs, what jobs is going on here. So here the copy percentage is showing here. If you can keep on refreshing it, you can see that percentage changes. I'm just going back. Refresh the screen. So here CPU is busy almost 90, 86%, almost 80s, upper 80s, and average in terms of 80 to 85%. And here if you look at the throughput, close to 6 is going up also now. If you look at now 5.9, it's gradually increasing now. If you look at that resource manager configurations, you can see that details here. The job is completed in 3 minutes 16 seconds, and that NFS operations also completed here. And here if you look at the high peak is 7.7 GB, we got it here, and then this is the throughput we got it of this operation. And then here the job, I'm just refreshing. The job also completed in 3 minutes 7 seconds. So these additional seconds for starting of the job. and the actual job completed in 3 minutes 7 seconds.